It happened on a stage in Texas, and the rest of the auto industry is still trying to figure out how to respond. No press release hinted at it. No leak had prepared anyone in the room for what they were about to see. Elon Musk walked out and raised a single piece of hardware above his head. Within 48 hours, executives at 3 major automakers had reportedly scheduled emergency meetings. One engineer who watched the clip said he felt physically ill. Another said it was over, not the casual kind of over, the kind people whisper. So what was it? Why is it rattling every rival in the electric vehicle race? And could it actually end the war for good? For more than 10 years, the world's largest carmakers have been locked in a battle that many believed would define the future of transportation. Electric vehicles didn't just add a new category to the market. They redirected the entire global auto industry. And one company seemed to be steering that future.
So we start with the car giant Tesla. It's raised its spending plans to more than $25 billion.
Tesla. But here's what most people forget. In the early days, almost nobody expected Tesla to hold the lead for long. The company looked bold and inventive, but also unstable, especially next to giants like Ford, General Motors, Toyota, and Volkswagen, corporations with generations of manufacturing muscle, precision engineering, and production networks spanning the globe. Plenty of experts assumed it was only a matter of time before these heavyweights caught up and pushed Tesla aside. And for a stretch, that prediction looked right. Rival EVs got sharper, more dependable, more livable. Battery technology improved faster than forecasters expected. Some analysts were already calling Tesla's lead a temporary thing, something that would quietly dissolve. Then Tesla unveiled something that changed the mood inside the industry overnight. It wasn't a new car. It wasn't a bigger battery. It wasn't a software update. It was a motor. But not just any motor. Engineers who examined it reportedly arrived at the same unsettling conclusion almost immediately. Tesla wasn't merely ahead of the pack anymore. It had stepped onto a tier most competitors weren't even close to reaching. And here's the part that really stung. It wasn't just how powerful or efficient the motor was. It was how nearly impossible it would be to replicate. Insiders quietly admitted that catching up could take years, maybe close to a decade. By the time anyone else got there, Tesla would already be somewhere new. Quick favor before we go further. If breakdowns like this one are your thing, hit subscribe and turn on notifications so you don't miss the next deep dive. It genuinely helps the channel keep these stories coming. So why this moment? Why would Tesla choose right now to drop something this disruptive? The answer is a little uncomfortable, and it starts with a truck almost nobody seems to want. Here's what most people miss. Tesla needed this breakthrough, and it needed it badly. The Cybertruck, once marketed as the future of transportation, had quietly turned into a liability. Despite years of buildup and global attention, sales reportedly fell well short of expectations. Reports suggest the situation got bad enough that close to 1 in 5 Cybertrucks registered in a single quarter went to companies tied to Musk himself, SpaceX and XAI among them. Internal registrations were padding the numbers. Recalls were chipping away at trust, and each new recall headline made it harder for the truck to shake its reputation as a product still working out basic kinks. And in a market suddenly flooded with electric options, Tesla's flagship product wasn't carrying its weight. Musk needed something undeniable, something the entire industry would be forced to react to, something that could shift the conversation away from a struggling truck and back toward Tesla's technological edge. And in a quiet engineering bay, far from the Cybertruck headlines, that something had already taken shape, breaking the rules. To understand why this motor shook the industry, you need to understand one stubborn truth about electric vehicle engineering. Physics doesn't bend easily. For years, the industry simply accepted that. Car makers around the world believed they were stuck with a painful trade-off. An electric car could be blisteringly fast and powerful, or it could be efficient and travel long distances on a charge. Doing both at once seemed almost out of reach. Engineers shrugged it off as just how electric motors worked. Push for performance, and the motor got heavy, overheated, bled energy, and demanded heavy-duty cooling just to survive. Build for efficiency instead, and the car felt flat, lacking the acceleration drivers actually wanted. That compromise was treated as an unbreakable law. Most companies assumed physics had already drawn the boundary, so they stopped pushing against it. Tesla didn't accept that. Its engineers went looking for a different answer entirely, and after years of trial and error, they built one of the most advanced electric motors ever placed in a consumer vehicle. At the heart of it sat something deceptively simple in theory, but brutally hard to execute: a carbon fiber-wrapped rotor. Think about that for a second. Inside every electric motor is a spinning rotor that, during operation, rotates at extraordinary speeds. The faster it spins, the more violently the forces inside try to tear it apart. Engineers call this centrifugal stress, and at high enough rotational speeds, it acts on every gram of metal inside the rotor like an invisible hand trying to fling it outward. Most conventional motors simply can't take that kind of pressure. They warp, they fly apart, they cook themselves into scrap long before they reach the speeds Tesla was targeting. Traditional manufacturers dealt with this by keeping rotor speeds conservative, which capped how much power a motor could realistically produce without destroying itself. Tesla solved the problem differently. It wrapped the rotor in carbon fiber, a material known for being both remarkably strong and remarkably light, originally developed for industries like aerospace, where the same strength-to-weight challenge applies. That wrap acted like armor, holding the rotor together even under extreme stress, while adding almost no extra weight to the overall motor. The payoff was striking. Tesla built a motor capable of spinning past 20,000 revolutions per minute, speeds typically reserved for specialized industrial equipment, not the sedan you drive your kids to school in. Let that sit for a second. But raw speed wasn't the real story. The real breakthrough was the stability Tesla achieved at those speeds. The carbon fiber wrap cut vibration and kept the rotor balanced, and that stability boosted magnetic performance, letting more electrical energy convert into actual motion instead of bleeding away as heat. That's the detail that quietly wrecks the competition. In a typical electric motor, a meaningful chunk of battery energy is lost to heat, noise, and vibration. Tesla clawed most of that back. More of the battery moves the car. Less of it goes to waste. Same battery, more range, more speed, less heat. And that kind of efficiency gain doesn't stay confined to one model. It compounds across every car Tesla builds going forward. The benefits reshaped what people expected from an EV. The motor produced massive instant torque and startling acceleration. It stayed efficient over long drives. It remained compact and light, while needing far less cooling than rival systems, and that detail matters more than people realize. Cooling hardware is heavy, expensive, and eats up space that could otherwise hold batteries, passengers, or cargo. Every other automaker has to bolt on pumps, radiators, coolant lines, and control electronics just to keep their motors from cooking themselves under hard use. Tesla quietly cut out a huge slice of that burden. The clearest demonstration came with the Tesla Model S Plaid. Picture it? A test track, a row of automotive journalists behind a barrier, phones up, expecting fast. Musk standing off to the side, hands in his pockets. The Plaid launches. Under 2 seconds later, it hits 60 miles an hour, and you can watch the footage as faces change in real time. One reporter actually steps back. Another lets out the kind of laugh people give when their brain hasn't caught up yet. The car outran hypercars worth millions, vehicles built by storied performance brands with decades of racing pedigree and price tags that would buy several houses. And the truly unbelievable part, It was still a comfortable luxury sedan that could carry passengers hundreds of miles on a single charge, with back seats, cup holders, and a trunk, not a stripped-down track special built to chase a single number. Engineers from rival brands reportedly bought Plaids, tore them apart in private labs, and walked away frustrated. The motor wasn't just better, it was built in a way that made copying it dangerous. Wrapping carbon fiber at production scale is a manufacturing nightmare. One small flaw, and the whole rotor becomes useless, which means a single bad batch can quietly destroy thousands of dollars in materials and labor before anyone notices the defect. Tesla solved that production puzzle before anyone else even attempted it, and did so quietly while the rest of the industry was still arguing over battery chemistry. For decades, the assumption was that drivers had to pick between speed and efficiency. Tesla proved otherwise, then built the solution cheaper, lighter, and easier to mass produce. And that's where this stops being about a single motor and starts being about something far more alarming for everyone else. Because the people inside Tesla's Fremont factory already know what's coming. They've been building toward it for years. Why rivals can't keep up? Plenty of automakers know how to build a flashy prototype. They unveil a sleek concept, pull in investors, dominate headlines for a news cycle. But building a handful of impressive cars is nothing like producing millions of them reliably. That's where most companies stumble, and it's exactly where Tesla has become one of the most feared names in the business. The industry is littered with companies that promised to reinvent transportation, generated huge excitement with beautiful concept vehicles, and then hit a wall the moment real production began. Making one advanced EV is hard. Making millions of them affordably, consistently, and profitably is an entirely different challenge. Tesla learned that lesson the hard way, years before its rivals did. While other companies poured their energy into design and marketing, Tesla spent years wrestling with manufacturing chaos behind the scenes. Broken production lines, robots malfunctioning, bottlenecks that nearly sank the company more than once. Those brutal years are paying off now in ways the industry can't ignore. Tesla recently revealed that its next-generation drive units, the same family built around that carbon fiber-wrapped motor, are being engineered not just for speed or efficiency, but for something even more important: manufacturability. That single shift could redefine the future of EV's manufacturability. Sounds like a boring engineering term, but it's the difference between a motor that looks great in a lab and one that can roll off an assembly line by the millions without driving the company into the ground. Tesla wants the entire drive unit, motor, electronics, gearbox, to cost roughly $1,000 to build. Some competitors spend 3 to 5 times that just to hit comparable performance. That's not a small gap. That's massive. Sit with that number. If a rival is spending $3,000 to $5,000 per drive unit and Tesla is spending $1,000, that difference multiplies across every vehicle built, across hundreds of thousands of cars a year. That's the kind of margin that quietly funds entire new product lines while everyone else is just trying to break even. What makes Tesla even more dangerous is that it keeps finding new ways to cut costs without sacrificing performance. It's working to remove rare earth materials from its motors, reducing dependence on supply chains heavily tied to China. At the same time, it's redesigning its electronics to use less of the costly silicon carbide that drives up component costs elsewhere. Cutting rare earth materials isn't a minor tweak. Those materials have been a choke point for the entire EV industry for years. If Tesla pulls it off, a big chunk of the supply chain leverage every competitor relies on quietly stops mattering. Each improvement feeds the next. Lower production costs let Tesla lower prices. Lower prices pull in more buyers. More buyers mean higher production volume. Higher volume means more manufacturing know-how, which drives costs down even further. The loop keeps tightening, and every rival is chasing a target that keeps moving away from them. Meanwhile, the competition is bleeding. Ford built genuinely impressive EVs like the Mustang Mach-E and the F-150 Lightning, yet reportedly lost enormous sums on its EV division. A company that's built cars for over a century and still can't turn a profit on electric ones. Lucid Motors built striking luxury EVs but kept burning cash at an alarming pace, leaning on outside investment just to keep production lines running. Rivian pulled in huge attention and investment, yet production costs stayed painfully high, and scaling up proved far harder than the early hype suggested. Even giants like General Motors and Volkswagen are dealing with delays, software trouble, and mounting questions about profitability, despite having far deeper pockets and far longer histories in the car business than Tesla does. This is what catching up to Tesla actually looks like from the inside. Not glamorous, not winning, just losing money slightly slower than the company next to you. Among global rivals, only BYD looks capable of challenging Tesla at real scale, mainly in lower-cost markets. But here's the catch. BYD's edge comes mostly from affordability, while Tesla is chasing something bigger, not just cheap EVs, but the most advanced and desirable electric vehicles in the world, built affordably at the same time. That combination is what makes Tesla so dangerous, and why more and more buyers believe the company is setting the pace for the future of transportation. And here's where the story takes an unexpected turn, because most people still think of Tesla as a car company, and that assumption might be the costliest mistake the entire auto industry has made. The hidden empire, Tesla's real advantage, comes from weaving multiple industries into one self-reinforcing system. And the new motor sits right at its center. Start with data. Every Tesla on the road is constantly collecting driving information. Road conditions, driver behavior, weather, traffic, unusual events. That matters because autonomous systems improve through real-world experience. And Tesla has gathered more of it than almost anyone on the planet. Unlike a competitor testing self-driving software on a small fleet of company-owned vehicles, Tesla is effectively running one of the largest distributed data collection experiments in automotive history, with ordinary customers unknowingly contributing miles of footage and sensor readings every single day. That edge compounds. More vehicles mean more data? More data sharpens the AI. Better AI attracts more buyers. More buyers generate even more data. Rivals can't simply buy their way into this advantage. They'd need years of vehicles on the road, and those vehicles would need to be desirable enough for people to actually buy them. Which brings it back to the motor. A cheaper, more efficient, harder-to-copy drive unit means more Teslas on more roads, generating data faster than anyone can match. Then there's the battery business. Tesla poured billions into battery production because batteries are the single most expensive part of an EV, often accounting for a third or more of the total cost of building the car. Its 4680 cells are built to boost energy density, cut costs, simplify manufacturing, and improve performance, all at once, which is exactly the kind of trade-off most of the industry assumed was impossible to solve cleanly. Most rivals still lean heavily on outside suppliers, paying someone else's markup on the priciest component in the car and locking themselves into supply contracts that limit how fast they can adjust pricing or chemistry. Tesla increasingly controls its own supply, and that shows up both in the price tag and the profit margin. The company also designs its own software, chips, power electronics, and vehicle systems, an approach almost no other automaker has fully committed to. When global chip shortages hit the auto industry hard, Tesla adapted faster than most rivals by rewriting its software for alternative chips on the fly. While competitors were forced to idle factories and delay shipments because they depended on parts they couldn't source. That flexibility reveals something important. Tesla behaves less like a traditional automaker and more like a technology company. Its manufacturing footprint tells the same story. Factories in Fremont, Shanghai, Berlin, and Austin forming a fast-growing global network, each one built not just to assemble cars, but to refine the production process itself, with future sites planned in Mexico and possibly India to push costs lower. and unlock new markets. And every one of those plants is being tooled to build that $1,000 drive unit at scale, meaning the cost advantage isn't confined to one factory or one country, it's baked into the entire global operation. Then, there's one of Tesla's most underrated weapons, the supercharger network. For years, critics treated it as a minor convenience. They were wrong. Tesla's chargers became one of its strongest advantages because they're fast, reliable, widespread, and simple to use. While rival networks have often suffered from broken equipment, glitchy payment apps, and long waits that erase any sense of convenience. Drivers on other networks have described pulling into stations only to find every plug taken, every screen frozen, or every connector incompatible, sometimes after driving out of their way specifically to reach that one station. Eventually, rivals essentially surrendered. Ford and General Motors adopted Tesla's charging standard so their own customers could use its infrastructure, a remarkable concession from companies that had spent years building their own competing networks. Think about how remarkable that is. Tesla's competitors now depend on Tesla's own network to improve their customer experience. Tesla profits even when a rival sells the car. That's not ordinary competition. That's ecosystem dominance. And every time a rival's driver plugs into a supercharger, Tesla learns something: charging patterns, peak demand, regional usage, hardware performance under real load. Even a lost vehicle sale can still be a win on the infrastructure side. So the motor sells more Teslas. The Teslas feed the network. The network feeds the data. The data feeds the AI. And somewhere in a server room most people will never hear about, that data is doing something else entirely. Something that worries competitors far more than any motor could. Where this is heading, the closer you look at Tesla, the harder it becomes to call it just a car company. On the surface, it builds electric vehicles. Underneath, it's becoming something much larger. A technology company built on energy, software, data, and artificial intelligence, with car manufacturing as just one visible layer of a much deeper operation. A clear example is Tesla's Dojo supercomputer, built specifically to train AI systems using enormous volumes of driving footage gathered from Teslas around the world. Instead of relying purely on general-purpose computing, Dojo is engineered to process that footage faster and more efficiently. Custom-built around the specific kind of video and sensor data that self-driving systems actually need to learn from, rather than the generic workloads most data centers are designed around. And here's the part most people miss. Modern AI improves by learning from massive amounts of real-world data, and the more cars Tesla puts on the road, the more its AI has to learn from. The new motor makes more cars possible. Dojo turns those cars into intelligence. Most of the industry rents its computing power, often from providers like NVIDIA or cloud platforms run by Amazon, Google, and Microsoft, which means every cycle of AI improvement comes with a bill attached and a dependency on someone else's hardware roadmap. Tesla chose a different path, building much of its own computing infrastructure, because it believes its future depends less on the cars it sells today and more on the intelligence those cars will run tomorrow. Every other automaker chasing AI-driven driving has to rent the compute, rent the data, and still figure out how to build the cars. Tesla does all three under one roof. Control the cars, and you control the data. Control the data, and you control the AI. Control the AI, and you control what driving looks like a decade from now. That isn't a head start. That's a different game entirely. It creates a cycle that almost feels unfair. Better motor technology lowers cost and boosts performance. That attracts more buyers. More cars on the road generate more data. More data sharpens the AI. Smarter AI improves self-driving. Better autonomy raises the value of every Tesla already out there. Higher value means higher profits, which get reinvested into research and hardware, making the next motor even more dangerous. The loop feeds itself and keeps getting stronger, and unlike a one-time advantage, It doesn't fade if Tesla slows down for a quarter or two. It just compounds a little slower until the next push. Many observers now argue the EV race was never really just about building cars. Tesla is competing on multiple fronts at once: batteries, software, manufacturing, artificial intelligence, real-world driving data, charging infrastructure, global production scale. Catching up in just one of those areas would take rivals years. Competing across all of them simultaneously is something almost no company on Earth is currently built to do. And every one of those fronts traces back to the same place: the motor, the piece of hardware Musk lifted onto that stage. It was never just a product. It's the doorway every other Tesla advantage walks through. A cheaper motor means cheaper cars. Cheaper cars mean more buyers. More buyers mean more data. More data means smarter AI. Smarter AI means a future Tesla owns outright, while everyone else has to rent access to it. Every executive at Ford, General Motors, Volkswagen, Toyota, Lucid, and Rivian watched that reveal. They saw the same piece of hardware you did. And the ones who actually understood what they were looking at probably didn't sleep that night because they weren't behind on one product, they were behind on the foundation every future product would be built on. There's no quick fix for that. You can't buy your way out of it. You can't patent your way around it. You can only try to build something equivalent, and Tesla already has a decade's head start. A gap measured not in months of engineering work, but in years of accumulated manufacturing knowledge, supply chain relationships, and real-world data that simply can't be purchased or fast-tracked. So the electric vehicle revolution is real, but it may not turn out the way most people originally expected. Instead of a balanced market with many equal players, what's forming looks more like a world shaped by one company moving faster, learning quicker, and building a deeply interconnected system. The rest of the industry is still struggling to understand, let alone replicate. The new motor wasn't the announcement. It was the signal. So what do you think? Is this the moment the electric vehicle war actually ends? Or is the competition far from finished? Could another company close the gap in the next 10 years? Or has it already grown too wide? Drop your honest take in the comments. I read every one, and the best debates always come from this community. Whether you think Tesla has already won this race or still has serious threats coming, I want to hear it. If you made it this far, hit that like button so more people see this breakdown, and subscribe if you haven't already. There's a lot more coming on the companies and technologies quietly reshaping the world, and you won't want to miss what's next.